Okay, we've now reached the point in the semester where we will begin working on interactive exercises in Dashboard in addition to the multiple choice exercises. These are ones where you'll have to fill in information on your own. So the first interactive exercises we have to work on are truth tables. So I'm going to work the first practice problem here for Chapter 7, Section D. Right? This is from the practice set. It tells me to create the truth table for if Q, then not P. Okay? So to construct a truth table, this will be easier for you in the interactive exercise because a lot of this will be done for you, but I'm just going to do it from scratch here. I have two simple statements here. This is one complex statement, a conditional, right? That's made up of two simple statements and some operators. So the simple statements here are Q and P. So I'll write those here. And then my complex statement is if Q, then not P. All right? And I like to divide, I'll extend this throughout the whole truth table later on, but I like to divide my simple statements from the complex statement that I'm providing the truth table for. You won't have to do that in the interactive exercise, but I'd like to just separate the left side from the right side. Okay, so I now need to provide the truth values for Q and P, and I need every possible combination. The way that I do that is I need to first figure out how many rows I'm going to need. Now the rule for that is you take the number of simple statements that you have, and the number of rows you're going to need is 2 to that number. So here I have two simple statements, so 2 to the power of 2 is 4. I'll need 4 rows. If it had 3 simple statements, it'd be 2 to the power of 3 equals 8 rows. If I have 4 simple statements, it'd be 2 to the power of 4 equals 16 rows. And at that point, you have a very large truth table, so hopefully we won't run across too many of those. But let's just go ahead and fill this in. I need 4 rows, as I said. The pattern here is you take that number, however many rows you need, and for your first simple statement, you will simply provide half of those with T's, and then follow that with half of them F's. All right? So in this case, I have 4 rows, so 2 T's followed by 2 F's. And then for the next one over, I'm going to basically repeat this sort of pattern, T followed by F, but I'm going to cut it in half. If I had 2 T's here, I'll start with 1 T followed by 1 F, and 1 T followed by 1 F. All right? And if I'd had 3 simple statements with 8 rows, I would have started with 4 T's followed by 4 F's, then 2 T's, 2 F's, 2 T's, 2 F's, finally followed by T, F, T, F, T, F, T, F. So this is the kind of pattern you'll always see with your last one. But again, this is provided for you in the truth tables in the interactive exercises. Just want to make sure you understand the idea though. Okay, now at this point, I don't really need to write down the truth values for Q and P right here because they're right here, but I'll go ahead and do it anyway just to make that clear. And this is again filled in for you in the interactive exercises. Now, we're almost ready to complete this truth table. The only question I really need to decide here is which one of these two operators to start with. Do I start with the conditional, the horseshoe, or do I start with the negation, the tilde? And the answer is simple. Whenever you have a choice between two operators like this, you always go with the tilde first. Always. So, and I will start right in this column right here then, under the tilde. And it says not P, so this column will have the opposite truth value of P. So if P is true, the negation is false. And if P is false, negation is true. Right, so P was TFTF, so tilde is FTFT. And then I need to complete the truth table by working on my main operator here. And remember, the rule for the horseshoe is fairly simple, maybe not obvious, but it's fairly simple. It simply says that the horseshoe is true whenever the antecedent is false. That part's a little odd, but you'll just have to memorize that. Whenever the antecedent is false, so if you see the Q is false, then the horseshoe is guaranteed to be true. And the other part of it is, if you see that the antecedent is true, then the whole thing will come out true, the conditional will come out true if the consequent is also true. So in this case, the consequent is the not part right here, right? This is not P, is the consequent. So I need to look at the column underneath the tilde. So if this is true, then is the tilde true? Well, it is here, so that's true. It isn't here, so that's false. and that's the value of my main operator. Now I'm circling my main operator here to show that this is the truth value, possible truth values for the complex statement. In the interactive exercises, you'll simply click on the horseshoe. That's how you'll select the main operator. But once you select the main operator and you have all this filled in, you should be able to hit submit and get it right.